This video is going to be a continuation of solving polynomials by factoring. And in this case, though, we're not going to have just quadratics. We're going to have higher degree polynomials, meaning that you may have powers that are cubes or fourths, etc. As long as that polynomial can be factored, even if it has higher powers, we can still use the same strategy as solving quadratics by factoring. So I just want to do a few examples in this video and show you how you can use this strategy for other examples too. So here I have a polynomial, solve 3x cubed minus 12x equals 0. So it's not a quadratic because our power is 3, right? So it's higher than just a square, but I'm going to be able to factor this. So as long as I can factor it, I can still use that strategy of setting it equal to 0 and then setting each factor equal to 0 to solve. I have equal to 0 to start, which is great. So now I'm just going to work on factoring the left side of this polynomial. I do notice that both of these groups have a factor of 3 and x in common. So I'm going to take out the GCF first here. When I do that from the first group, I still have an x squared left. And from the second group, I have a minus 4 left, right? 12 divided by 3 is 4, but the x has already come out. And if you're still seeing squares left over, or again, higher powers, you're just going to go and keep factoring. So x squared minus 4, it factors into x plus 2x minus 2. And now notice that all of my factors are as broken as I can go, right? There's no more squares or anything else in common. So now I'm ready to set each of those factors equal to 0. So I'm using the same exact strategy as solving quadratics by factoring it, just that now I have 3 parts instead of just 2 parts. So I'm going to set 3x equal to 0, x plus 2 equals 0, and x minus 2 equal to 0. So here I'm going to divide both sides by 3. Here I'm going to subtract 2 from both sides. And here I'm going to add 2 to both sides. So in this case, I have 3 solutions. And we can also check it the same way. So if you want to take any of these answers and plug it back into the original polynomial here, you should get a nice true statement. You can see 0 works right away because this makes this term 0 and this one, and 0 minus 0 is 0. So any of these answers should be able to check back in the original, and you can verify that you've done it correctly. Now, another thing to note is that the degree or the highest power will tell you up to how many different answers you can have. If you include repeats and imaginary answers too, then it tells you exactly how many answers. But if we're talking about real numbers here, it tells you up to how many different answers you can have. So to have 3 answers here when I have a cube is perfectly reasonable and very much expected. And the second example I have here for you guys, you can see that we are starting with equals 0, which is great. Just makes it a little bit easier when we're solving by factoring. And the left side is kind of factored, although I still see a square here. So what I do want to do is I do want to break this down as much as I can. So if I still see squares, higher powers like this, I do want to try to keep factoring. So the first term, or the first group, I'm just going to bring down. And then I'm going to work on factoring this here. And again, you can use trial and error here. You can use factoring by grouping. You may be doing work off to the side for this, right? So just because I'm jumping to the answer here, it doesn't mean that you shouldn't be doing work out on paper at this point. Again, in this video here, it assumes that you already know how to factor, so you should be pretty comfortable following along with the steps, quick version of the steps. But you may need to pause the video at this point, and again, try factoring this on your own first. Do that practice and then come back when you're ready. Now, the first term is a 2x squared, so it's got to be a 2x and an x if I'm using the trial and error strategy. Your last term is 18, so there's lots of factor pairs there, right? 1 and 18, 2 and 9, 3 and 6. So if you're doing trial by error, you have quite a bit to try to figure out the right combination so that we can get that 15 in the middle. And if I'm looking at my notes here, I see that 3 and 6 are the one that's going to work. So the 3 goes here and the 6 goes here. And if you multiply this through, you can see you get a 12x and a 3x, which gives you that 15x in the middle. So again, there is extra work that's going on in here. So if you need to pause your video and do factoring, on your own, really think through the steps in more detail than just talking it out with me, please go ahead and do that. And remember that we have lots of videos on factoring trinomials, so things with 3 terms in them. And we have 2 main strategies, right? We have trial and error method, and we have the grouping method. So you're welcome to use either strategy for factoring. Once I have everything factored, again, I don't see anything else in common between the individual factors. I don't see any higher powers or things. Now I set each of those factors equal to 0. And I just start solving each of these one at a time. So in the first case, I add 1 to both sides and divide by 5. So my first solution is 1/5. In the second case, I subtract 3 and divide by 2. So my second answer is -3/2. And in the last case, I'm subtracting 6. So my last answer is just -6 here. So again, I have 3 answers. I won't check this, but if you do want to check your solutions, you can absolutely check it by plugging it back into the original equation. All right, let's try another example. So here, solve 2x cubed minus 4x squared minus 30x equals 0. Again, the only thing we have right now is factoring for our solving process for these higher power polynomials, right? Squares, cubes, and so on. So you're going to have to try to factor this. So the first thing I'm going to notice is I do have a common factor. All 3 terms have at least one x in them and a factor of 2. So I'm going to start by taking that out first. When I do that, I have an x squared left here. 4 divided by 2 is 2, so I have a 2x left in the middle. And then 30 divided by 2 is 15. The x is already taken out, so I have a -15 there. So when you have those higher powers as well, really look for a GCF. That's probably going to be a way that you're going to start, at least for now, because we're sort of just introducing this in this video. So we have our basic factoring techniques. So look for your common factors first, and then after that, see, okay, well, now what can I still factor? So I still see a square here, so I know that I'm going to do a little bit more breaking down in this case. So, or at least I'm going to check to see if I can. Sometimes it could be possible that something is prime and can't be broken down. But from right now, most of our examples are going to be able to be factored, again, in general. So for x squared, it's going to be x times x. For 15, again, let's see, the one that's going to work here is 5 and 3. -5 and +3 will get us that -2x in the middle. Excuse me. So then I'm going to go ahead and I'm going to just keep solving. I set each piece equal to 0. In the first case, I divide by 2, and my first answer there is 0. In the second case, I add 5. I have a second answer of 5. And in the last case, I subtract 3, and my final answer is -3. Now, again, my power is a 3 here, so there's no surprise that I have 3 answers. Again, I could have up to 3 different answers when I'm solving this. Now, the last example I want to do, it does take us back to a quadratic. You do have a square there, but it's more of an application problem. So factoring to solve equations is actually really helpful in lots of scenarios. And here's another one. It says, find the x-intercepts of the graph of y equals x squared minus 5x plus 4. So the first thing you want to remember is, well, what is an x-intercept? That is the point where the graph touches or crosses the x-axis. And if you think about your x-axis, what that means is that the y value in that case is 0. So that is the big thing for our intercept, or our x-intercept, is that the y value is 0. So what's happening is I'm going to replace y with 0 in this problem, and you're going to see that I'm actually doing the same exact things I was already doing. I'm just looking at it as an application instead. So I set that y equal to 0 here because I'm looking for the x-intercept, and now I can use my factoring strategies to solve. It doesn't matter which side the 0 is on, as long as one side is 0. So this is perfectly fine here. When I factor that, I get -1 and -4 as my factors. That would work. That will multiply out and give me this original equation. And then I can go ahead and set each factor equal to 0. So my first answer is 1, and my second answer is 4 here. So the x-intercepts are at 1, 0 and 4, 0. Again, I'm writing them in full point form. You can just read and see how they want the answers written. If they just want the answer, then 1 and 4 is fine. But if they want it as order pairs or points, then it would be 1, 0 and 4, 0, right? Because that y value is 0. Now, another nice thing to do to check, and I'm going to bring up my Desmos app here. All right, so this is the Desmos app on my phone, and I'll see if I can get you to see screen a little bit. Oh, maybe not. Let's see. Oh, let's try moving it out. All right, just wanted to get my app set for you guys so you could see it. So this is the Desmos app. What I can do here is I can write the original problem in. So if you read back, it stated y equals x squared minus 5x plus 4. That was the original equation that we were given, right? And we were asked to find the, let's see what we were finding, the x-intercepts here. So if I graph it, I actually can visually tap and see those x-intercepts right on my screen here. So again, I'm using the app, so it is a touch screen on my phone. So if I tap where those intercepts look like they should be, then I can see that the points are 1, 0, and 4, 0, which are the exact values that I got. So it's really nice to be able to, I'm just kind of zooming into, different settings here, but it's really nice to be able to check some of these questions with a graphing utility as well. So like a graphing calculator. So I can type in the original, see where I think those x-intercepts should be, and I can see here, hey, they should be at 1 and 4. I do the algebra, and that's another way I can check my answer. So I can use the algebra and the visual together, make sure that they both make sense and they align. And then again, I have another way that I can go ahead and check as well. So that's just a nice little tip here. One last thing to note here about graphs. So so you'll notice here, right, for this one, let's see. The graph looked like this. I was able to see the intercepts right here. So when I had 2 solutions to the algebra, I had 2 intercepts. Again, these are x-intercepts on the graph. So I was able to visually see these. There's other things that could happen too. So for instance, if you had, just a little side note here, maybe your graph looked like this instead. So maybe it just has 1 x-intercept. Then what happens here if you have only 1 unique solution, you would have 1 x-intercept. Now, 1 unique solution, what's happening is you have a repeat solution. So when you're doing the algebra, for instance, you're getting the same answer twice. So maybe you're solving and you get the answer x equals 3 and then x equals 3 again. So technically you do have 2 answers, but it's the same number. So that's why on the graph, visually, you're only seeing 1 intercept there. So that's really pretty interesting as well. So you can still check those. And the other thing that can happen too, for instance, I'll do it upside down one just to kind of mix it up. So let's say your graph looks like this and it doesn't touch at all. So when that happens, there are no real solutions when there are no x-intercepts. Now, the graph of quadratics you will see is a U-shape. So it's either an upward U or a downward U. So you're going to see U-shapes when you have squares. If you have more complicated polynomials with higher powers, they'll have more curves and bumps and turns to them. But still, those solutions match with those x-intercepts on the graph, which is a really cool and interesting way to check your work as well. If there are no real solutions to the problem, then there will be no x-intercepts. So we will actually see, you will see eventually that when there's no real solutions, there are imaginary answers. So there's still answers there, they're not real numbers. So we haven't gotten to that point yet. But this is a nice way to just check visually. You can also check other problems too that don't have a y equals. So what you would do in that case, and again, this is going a little bit extra here, but it's just a nice way to check your work, is you would still have it equal to 0. So that is really important. But instead of using a 0, again, on the graph and calculator, just pretend that is your y. So we're going to do y equals, and then 2x cubed minus 4x squared minus 30x. And again, I'm not going to type in equals 0. Instead, I'll make that 0 a y when I'm using a graphing calculator. Again, it just makes it a lot easier to deal with. And you can see this is the graph right here. And if you look, it does actually cross that axis 1, 2, 3 times. So I'm doing the example we just did previously to it, where we had 3 answers here. And you can see those x-intercepts match up with my 3 answers here. So there's a -3, the 0, and the 5. So there is this really nice connection between the x-intercepts on a graph and when you're solving an equation that is set equal to 0, because we can use that x-intercept idea or that y value of 0 to help us check our solutions. So just a little bit bonus kind of material there that if you're more of a visual person, you may find it really helpful to be able to graph and see how those solutions are coming into play visually as well.